Okay, so we're going to go ahead and just look into cube roots. We're going to look at the inverse of a cube root. Okay, that's going to be one of our things that we're going to find. We're going to look at the domain, the inverse, and we're going to sketch both the cube root of x and the inverse of x. And we're going to start by just plugging this thing into Desmos. And in order to do that, I'm going to use the little keyboard. I'm going to come over to the word functions. I'm going to come down to where it says miscellaneous, and I'm going to use this symbol right there. I'm going to put the cube root of x in. Let's call it f of x. Okay. And just looking at this graph in red, the cube root of x, x and the cube root, we can tell that the domain is negative infinity to positive infinity. And it is a function because for every single x, there is only one y value. You'll see as I put those vertical lines, it only touches at one time. So that tells us it is considered a function. Okay. And now what we're going to do is we're going to fill in some table off of it. So let's go ahead and let's just pick some points and we'll start putting some data in there. So I know automatically that the point 0 is 0. Okay. I also know that if I just pick another point on here, I can say, well, let's go ahead and trace this up. I've got 1 and 1. So let's go ahead and pick some points. I've got 1 and 1. I also have, it looks like negative 1, negative 1. Okay. And negative 1, and maybe pick another 2. So let's pick this one. That looks like a good point right there. That was at negative 8 and 2. Okay. Negative 8 and 2. And maybe I can come over here, or I'm sorry, negative 2. And then I'll come over here, maybe it looks like that same point is over there, except it's positive and positive, so 8 and positive 2. Okay, 8 and positive 2. Well, those are points on the cube root of x. So I'm going to go ahead and make an inverse table. Okay, I'm going to add a table, and let's go ahead and do the inverse table, which is right here. And I'll write that here, inverse table. Okay. And when we do the inverse, one of the things that we learned, or should have learned by now, is that all we got to do is flip the points around. So the inverse is just the flipping of the domain and the range. So 0, 0 stays the same because when you flip those are the same. 0, 0. 1, 1 also, that's really nice. 1, 1, we flip that, still the same. Negative 1 and negative 1. Okay. And then we got the other one, negative 2 and negative 8. And 2 and 8. Okay, and that's how we find the inverse points. Just flip them. And once we have that, I'm just going to change the colors real quick so we know that it looks just a little bit different. Maybe paint instead of green, we'll come up here and we'll change these to blue. Okay, and let's see here. Okay, we can actually see those points. Now it's really kind of hard to see exactly what that looks like because that's one of the questions that goes with this. So let's do this algebraically. So these are inverse points that are there. Okay, and you can see a couple of them, and some of them actually kind of overlap because we picked those points to work that way. So let's find the inverse. So the first thing we need to do is we just say, well, y equals to the cube root of x. The question is, well, how do we get rid of a cube root? Well, in order to get rid of a cube root, you may have learned this before, you cube it. Just like in order to get rid of a square root, you square it. So a cube root, you use the power of 3. What you do to one side, you do to the other. And the cube root and the cube will cancel. We're left with x equals to y cubed. And now one of the other things we learned is once we have the inverse, we just flip it. We say, okay, well, the inverse, f inverse of x equals to x cubed. And there is our inverse. Let's just go ahead and graph it while we're here, okay? And I'm going to come down here. I'm going to put x cubed in. G of x. Remember, Desmos doesn't like all that inverse stuff, so just x cubed. And it goes through there. Remember, we can also check to see if they're inverses by the composition. So that's one thing that I always do. Let's put them inside of each other. I'm going to take y equals to x. I put the line through there. Check it out. It's actually a really cool looking graph. Okay, you can tell they're a reflection over y equals x, but just in case you're having a hard time with that, and it's easier for you to do the composition, I'm going to say f of g of x. And I'm going to plug that in, and look at that. It switches the y equals x color to that one. And if I flip it the other direction, g of f of x, it switches it to the green. So you can tell that they are inverses. So the inverse of a cube root is the cubic, and the inverse of the cubic is